Hello everyone, in this video let's discuss how to solve the uniform cost search algorithm problem in artificial intelligence and machine learning. So if we see the theory part of the UCS, that is uniform cost search, the features of this uniform cost search is it allows backtracking. So what is backtracking? In one path, if you not get the favorable answer, you will be trying out the another path like that. Next, it will reach the goal node. So it will reach the final or the goal node. Next, it uses the priority queue. So it will use the priority queue. So what will be the priority? Least cost path. Least cost path. So which path will be having the least cost? It will give the priority to that. Next, node expansion based on cost path. So I said no, which will be having the lowest cost, we will be moving with that path. Next, if we see the advantage, it will use the optimal solution. Why optimal solution? Because we are using the low cost paths. Next, disadvantage is can stuck in the infinite loop. So let's solve these three problems. You will get the problem easily. Now if we see the first problem, the initial node from which it starts is A. So from A, I must move to another node or another states. So from A I can move to B using 2, or from A I can move to C using 3. But we will be using the least cost path. So from A I will be moving to B using cost of 2. Next, from B I can only move to D because I can't go back to A because I came from A itself. So from B to D the cost is 1. So D is my final state. So I have reached it. So what will be the cost? 2 plus 1 will be 3. So 3 is the total cost. Now let's go with the second question. So the second question, A is my initial node. From A I can go either to C or I can move to B. So which one I will be choosing? I will be choosing the least cost path. So from A to C the cost is 3. From A to B cost is 7. So among 7 and 3, 3 is the smaller one. So I will be moving to C using cost 3. Now from C I can't go back to A because A is already traveled. From C I can go to D, or from C I can go to B. So the cost of moving from C to D is 9. From C to B it is 2. So I will be choosing the least cost with 2. That is cost of the path is 2. From C I will be moving to B. Next, from B I can't go back to C because C is traveled. From C, the only option is to move to E. Now, from B, I can't go back to C because C is already traveled. From B, I can only move to E. So, from B to E, the cost is 6. Now, from E, I can go to D, or I can go to F, or I can go to F. From E, I can go to D, I can go to F, or I can go to G. So, if you see the path cost, from E to D it is 3, E to F it is 2, E to G it is 1. So the least cost is from E to G with cost of 1. So G is my final state. Now we have arrived at the final state. Now add 3 plus 2 will be 5, 5 plus 6 will be 11, 11 plus 1 will be 12. So the total path cost is 12. Now let's move on to the third question. This is little bit tricky. Now if we see, A is my initial node. From A I will be moving. From A I can go to C or I can go to B. So the cost of moving from A to C is 3. From A to B it is 7. So among these two the smaller is from A to C with cost of 3. From C I can move either to D or I can move to B. The cost of moving from C to D is 9. From C to B it is 2. So the least cost is from C to B with cost of 2. Now B is also traveled. From B I can only move to E. Only possible path is to moving to E with the cost of 6. Next, from E I can go either to D or I can go to F or I can go to G. But the least cost is from E to G with 1. But from G I can move to any of the further state or I can move to my final state. So but also we must move to G with the cost of 1. Since I can't go to my final state and get my final value, I will be backtracking. So this is the backtracking technique. So if I backtrack from G I will come back to E with cost of 1. Now from E I can go to D or I can go to F. The cost of moving from E to D is 3, E to F is 2. So I must choose the shortest path. From E I will go to F with cost of 2. But F can't go to my final state or F can't go further. So I will be backtracking from F to E again. So the cost of moving from F to E is 2. Next, only one path is left from E to D. So the cost is 3. From E I will be moving to D with cost of 3. Now from D I can only go to H because I can't go back to C. So from D to H the cost is 13 and H is my final state, so I will stop here. So find the total path cost. 3 plus 2 will be 5, 5 plus 6 will be 11, 11 plus 1 will be 12, 12 plus 1 will be 13, 13 plus 2 will be 15, 15 plus 2 will be 17, 17 plus 3 will be 20, 20 plus 13 will be 33. Now we got the final path cost, that is the least cost path, using backtracking technique also. So you can't directly go from E to D and D to H. You must use the backtracking in the uniform cost search because you will be moving with the priority. See here, priority queue. So who will be having the priority mode? Who will be having the less path cost? So since priority queue is there and priority will be more for the shortest path, first you must move to the shortest path. If you not got the favorable answer, then you will backtrack to the normal node which you are having and then we will go to the possible paths. So hope you understood how to solve the uniform cost search algorithm problem in artificial intelligence and machine learning. If you have any doubt, please do comment below. I will try to clarify it. If you liked the video, please subscribe and support us because your one support motivates us to make more engineering related videos. Thank you.